through the years, long antedating the appearance of H5N1 highly pathogenic virus. As part of that influenza basic research was intensive study of host adaptation, transmissibility of influenza viruses, pathogenesis, and virulence. And integral to that study has always been the issue of gain of function research, not only for influenza, but essentially for all infectious diseases research. Now, there are a few ways to look at gain of function research. There's the naturally occurring mutations which naturally give gain of function, and investigators study these effects on the phenotypes of interest. Does this mutation make something more transmissible, more pathogenic, or adapt to host better? Or, what historically investigators have done is to actually create gain of function by making mutations, passage adaptation, or other newer genetic techniques such as reverse genetics and genetic reassortment. When we do that, often some phenotypes appear and others disappear. For example, it is commonly seen that when you increase a transmissibility, you may see a decrease in pathogenesis, or vice versa. You may deliberately increase pathogenesis and see a decrease in transmissibility. But the bottom line is that gain and loss of function research is critical to understanding disease pathogenesis, antimicrobial resistance, and host responses, as well as to developing better techniques of surveillance, vaccines, and therapeutics. Specifically, to gain of function research on HPAI H5N1. What we're talking about now is the gain of function research in studies that increase predominantly the transmissibility, as is the case that I'm going to get into in a moment, as well as pathogenesis and alteration of host range of the virus.